All right. Let me go to what was this thing? The question paper we were using yesterday. I think it was here. Yes. Okay, let's try this one. Let's try this one. I think someone asked me to do this one, and I said I'll do it today. Ne? Okay. You can still see my shared screen, right?
Yes, we can. I can.
All right. Uh, Not this. So with problems based on projectiles, right? If it's one where the object being projected starts from the ground and back to the ground, right? So I always like drawing my what is this? Essentially my the schematic illustration of what has been given to us in the problem statement. Do that first. Okay. One red. Right. So the diagram below shows the path of a projectile. It takes the projectile 35 seconds to reach the target. Right. So you've been given a schematic illustration, right, of the problem above. Right. They say you have the diagram below shows the path of a projectile. So the path of this projectile, this is projected from this point, right? It reaches the maximum height it can go up to, and then it falls back to the ground, right? So as far as what you've been given the initial velocity, right? And then you are also given the time it takes. It takes the projectile 35 seconds to reach the target, right? So if we were to call the starting point A, the apex B, and then the destination C. Essentially, what this means is that it took this projectile 35 seconds to move from point A to point C.
See.
We are together here, no?
Yes, yes.
Right. Now the question here is calculate the angle of projection of the projectile. Right. Calculate the angle of projection. So they are looking for the angle at which um, this object was projected. So the angle theta, right? That's the angle theta, right? This, right, represents the initial velocity 450, right? And then as far as projectiles, you always have, because our projectile is at an angle in this case, right? We have to resolve it into its components. Right? It's going to have this component, right? Initial velocity in the horizontal direction, and then the vertical component, which we will call the initial velocity in the y direction. Right. Now, uy being the vertical component is going to be equal to u sine theta, right? And then u here we are given it is 450. So essentially this is 450 sine theta, right? And then UH being the horizontal component is going to be U cos theta. U is 450. So U cos theta is 450 sine theta. Right? That is what essentially we've been given. We know that when the projectile reaches the apex, right, the velocity of the projectile is 0 at this point. So essentially, it means we have, let me just place this here. It means essentially we have Vy, and then it is equal to 0 meters per second, right? Remember that, right? As the projectile approaches the apex, right, the velocity decreases. Why does the velocity decreases? Right, it decreases because of gravitational acceleration. Right, the only quantity that is able to change velocity is acceleration. Right, if acceleration changes, then the velocity changes. Now here, right, on this side of the projectile, right, as it approaches the apex, G, because G is always acting downward, right, it means it essentially takes away, right, from the projectile. It takes away velocity from the projectile. Hence, essentially, the maximum velocity that we get at the bottom here, right? As soon as this is projected, right, at this point, that is where you get your maximum velocity, right? As this approaches the apex, what happens to the velocity in the y direction, right, is that it decreases, and it decreases because of gravitational acceleration. So because, right, on this side of the projectile, the gravitational acceleration is essentially opposing the motion, right? That is why the velocity decreases, right? And then, of course, on this side of the projectile, from the apex to the destination or back to the ground, right? On this side of the projectile, G is essentially in the same direction as the motion. Hence, from here back to the ground, right, the velocity of the projectile increases, right? Now, as far as the velocity or the component of the velocity in the horizontal direction, right, there is no acceleration that influences the projectile in the horizontal direction. Therefore, this doesn't change, right? So on this side of the projectile, as well as on this side, the horizontal component remains the same. So it remains UH. Even at this point, it will still be UH, right, just before it hits the ground. Right. So as far as the videos, this is what you were supposed to take away from them. Are we together?
Yes, sir.
Right. Now, as far as what else we've been given, right, we are told the initial velocity. The initial velocity gives us this as well as this, right? And then we are also told that it takes the projectile 35 seconds to reach the target. So essentially to move from here, right? So from A to C is 35 seconds, right? Now, what does that tell us? Essentially, we know that, right, from here to B, right, the time is essentially, we can take it as TAB, right? The time it takes the projectile to move from A to B, we're going to take as TAB, right? Now, the time it takes the projectile to move from A to B is the same time it takes the projectile to move from B to C, right? So essentially meaning that TAB is equal to TBC. Are we still together here?
Yes, sir.
Right. So that essentially means that you are able to express any one of these in terms of the other one, right? Meaningly, if now you wanted to calculate TAC, right, which is from A to B, I mean from A to C, right? If from here to here is equal to TAB, right? It essentially means that this will be TAB plus TBC, which is equal to TAB. So instead of calling this TBC, we can just simply call it TAB, right? Meaningly, TAC is 2 times TAB. Are we still together here? Hello?
Yes, sir.
Right. So essentially, this is what we've been given. This is essentially what we have been given, right? So the angle that we have to calculate, Now, this is the thing with projectiles, that especially when having to calculate the angle, right? It is important that you make use of what has been given, right? What has been given essentially contextualizes the problem statements as well as the question based on the problem statement, right? It gives you context as to the angle that we want here, right? Is the angle we get if the projectile takes 35 seconds to move from A to C. Am I making sense here? Hello? Hello? What's going on? Can you guys hear me?
Yes, we can hear you, sir.
Can hear you, sir.
Right. So I asked if I'm still making sense, and it was silent in here, as if I'm talking on my own, right? So what I said is that it is very important, and especially for questions where you have to calculate the angle of projection, that you definitely must make use of the information that has been given, because the information that has been given gives context as to how you must calculate this, right? We're not just looking for the angle of projection, we are looking for the angle of projection when the projectile takes 35 seconds to move from the initial point to the last point, right? Similarly, had you been given, say, the range instead, right? Had you been given the range, right? So had you been given this, had you been given the range, right? Had you been given the range and then asked to calculate the angle of projection, you would have to use the range, right? Because the range contextualizes the question, right? It means that they want us to calculate the angle of projection when the range is such and such. Are we clear?
Yes.
Right. For problems based on projectiles, always use the given information, right? Especially for questions where they want us to calculate the angle of projection, right? Now, if this is the case, and we've been given TAC essentially, because they said it takes the projectile 35 seconds to reach the target. So to move from A to C. So TAC is equal to this, and then also TAC is 35 seconds. All right. Now let us look at how we can use that information to calculate the angle of projection for this one. All right. The information we have as far as the angle of projection, we have, so we haven't been given the range. Obviously, we cannot use that, which means there won't be a need to use this, because remember, this we are only able to use when we have to calculate the range. The only formula that we use as far as the range or along the horizontal plane, right, is the range or the horizontal displacement is equal to UH times TAC. Right? As far as the motion along the horizontal plane, this is the only formula that we can use there. Right? All the other formulas do not apply. Right? We have this one. V is equal to U plus AT. This we cannot use because there's no acceleration, right, along the horizontal plane. So it means
So, sir,
yes.
no, it's okay, sir. It's okay. Sorry for that.
You got it. Whatever you wanted to ask.
Yes, sir. Because you said horizontal now. Because I thought that the A would be gravity, but when I heard you say horizontal, I understood this.
Yes, or only for horizontal. So I'm giving you perspective as to why this is the only formula that we're able to use along the horizontal plane, right? Because remember, you have 4 kinematic equations, or what you like calling it, equations of motion, right? You have 4 equations of motion. So I'm saying this is the only one that we can use for the motion along the horizontal plane, right? And now I'm explaining why we cannot use the other ones. This we cannot use because there's no acceleration along the horizontal plane, all right? And then you have S is equal to UT plus half AT squared. Same story with this one, right? If you take away this, then essentially you are left with that, right? Because the acceleration is 0. It means if you take away this, then essentially you are left with S is equal to U times T, which is the same as this, right? And then you also have S is equal to U plus the average velocity divided by 2. The average velocity, which is initial plus final divided by 2 times T, right? This is essentially the same as that. Why? Because the initial and final velocities are the same. So if you say UH plus UH divided by 2, that gives you UH. So this goes back to this formula. Do you understand what I'm saying?
Yes, sir.
Right? And then the last one is V squared is equal to U squared plus 2AS. Right? Again, acceleration is 0, which means that one goes away. And then V squared is equal to U squared. That essentially you cannot use, right? Because this is equal to that, right? So this here is the only formula that you can use for motion along the horizontal plane for projectiles, right? Now, because we don't have the range, right? It means we obviously cannot use this, right? Meaningly, we won't be able to use that as well, right? That means we can only use this, right? As far as using that, we have the initial velocity, right? If you look at this side of the projectile, right, we're looking for theta, right? We have the initial velocity, we have the final velocity, and we have essentially the time, right? So that means we can use final. So Vy is equal to Uy plus GT, right? We are able to use this formula, right? Again, looking at the projectile on this side of the projectile, right? On this side of the projectile, right, the projectile is still going up or is still going towards the apex, meaning that G on this side is negative, right? So that is to say, essentially, if G is negative, it means that will be minus, right? Also, because we're looking at this side of the projectile, it means the time it takes the projectile to move from here to B, which is TAB. So this, to give us context, is TAB, right? We know that Vy, right, at this point at the apex is equal to 0, so that's 0, right? This is equal to that. G is 9.8, and then the time we can get, right, based on this relationship, right? Based on this relationship. right? So if TAC is equal to 2 times TAB, right? TAC has been given to us as 35 seconds to TAB. That means to get TAB, you simply divide sides by 2, and this gives us TAB. What is 35 divided by 2?
17.5.
17.5 seconds. All right, so we have TAB. Now we substitute this back to that formula. All right. So we have 0 is equal to UY, which is 450 sine theta minus 9.8. So 9.8 into TAB, which is 17.5. Right.
So I just have a question, sir.
Ah.
So the acceleration, the 9.8, isn't that the minus 9.8
Yes.
times 17.5? So that okay.
That is
Because
what it comes
so
from.
that yes, but I understand that yes, but inside doesn't that also become a minus 9.8? That makes the minus times the minus positive.
No. So this is what I did here. Right. So remember, initially this is plus. Right. So if we took that approach, it would mean that's plus. And this
Oh, I
is
understand. Sorry
negative.
for that.
Do you see what I did now?
Yes, sir.
Right. Okay, let's just keep it like this for context. It's fine. Right. And then negative 9.8 times 17.5 is 171, negative 171.5. Right. And then, of course,
Okay.
right, you take that to that side, and the sign changes. So then you'll be left with 450 sine theta is equal to 171.5. And then, of course, you divide both sides by 450. Right. And this leaves us with sine theta is equal to, sine theta is equal to this. And then to get theta, theta will be equal to arc sine of this. Which is, so arc sine
2.229. 229.
229 degrees. Are we all getting the same thing? Well, I'm getting 22.
I'm getting 22.403.
So this is 22,403 degrees.
0.4.
Right, I'm getting 22,403 degrees. Right, and that becomes your angle. Right, any questions here?
Okay, sir, I don't have a question on this one. I think I'm happy with this one. But
Okay.
there was another one that is in one of our textbooks, the red textbooks that we have. This one is, I think this one is different. I would like for you to explain it, even if you don't calculate it,
Okay.
but you explain the procedure actually.
Okay. What is the question? Is there any like similar question to the ones that are on Moodle? Okay, let me just see.
I I think there is one that is similar.
Okay, let me just see.
Out this one, maybe you will find something that is similar to this one that I want you to explain.
The one
On
is
our red books,
red books.
on our red books, it's on page 26, activity 1.4, number 10.
Might be similar. On page?
On page 26, activity 1.4, number 10.
Activity 1.4, number 10. Is
Yes.
it this one?
An object is projected at such an angle. Yes. Yes, it is that one.
Okay.
I think that one is slightly different.
Second? All right. Okay. An object is projected an angle of as an angle theta so that the maximum horizontal displacement is 5 times the maximum height. Okay. That is okay. We have an angle theta here, and then we know that's UH, that's UH, that's UH. This is H max. This is UY. This is Vy, which is 0 meters per second. Right, and then here we know we have the range or displacement along the horizontal plane. Right. An object is projected at an angle theta so that the maximum horizontal displacement so SH is 5 times the maximum height. So essentially the range is 5 times H max. So this is 5H max, right, which essentially gives us an equation, right? The initial velocity is 200 meters per second, right? Now, if that's the case, right, that essentially tells us that this initial velocity is 200 meters per second, right? If that's the case, it means uy being u sine theta is equal to 200 sine theta. And then UH, right, UH being equal to U cos theta is going to be 200 cos theta. Right, that is all we've been given. Right, and then of course, we can call this point A, call that point B, call this C. Right, so now they're asking us to calculate the angle of projection, right, when the maximum horizontal displacement is 5 times that of the maximum height, right? We know we only have one equation for this, right? And then as far as H max, there's a number of equations that we can use for H max, right? Because H max we get along the vertical plane, right? So this goes back to using that information that has been given, but they don't want us to calculate the angle of projection, but they want us to calculate the angle of projection when this is 5 times that. So, which means we have to make use of this relationship, of this relation, right? Looking at SH, right? SH, what is SH equal to? UH times TAC, right? All right, SH is equal to UH times TAC. And then we know that TAC we know is equal to 2 times AB, right? That's right. Right. Now, we haven't been given the time here. All right, we haven't been given the time. All right, sorry, I just wanna send a text to this person quickly. They just tried calling me. Right. Right, sorry about that. Right. Now, because we haven't been given the time, right, be it TAB or TAC, right, it means we are probably going to have to manipulate one of the kinematic equations, right, and express it in terms of time, meaningly one of the one of the equations of motion is Vy is equal to Uy plus GT, right? GT AB, right? That is when looking at the projectile as it moves from point A to point B, right? We know that this is equal to 0. This here is equal to 200 sine theta, right? G is negative 9.8, and this is what we'd be looking for, right? So because we do not have time, right, we have to express time in terms of the velocity. So meaningly, we know Vy is equal to 0. This here is 200 sine theta. Then this will become negative. Why? Because G is negative. So this will become negative 9.8 TAB. Now you take this, transpose it to that side, and it becomes positive. So this becomes positive 9.8 TAB is equal to 200 sine theta, right? And then, of course, you now express TAB in terms of the velocity. So you divide both sides by 9,8, right? Leaving TAB as the subject of the formula. And then what is 200 divided by 9,8? So I'm getting
20.48
20,08 theta.
theta.
Yes. All right. So because we haven't been given time, right? It's the time it takes the projectile to reach its destination, or the time it takes for the projectile to reach the apex, right? It means we have to express the time in terms of sine theta, right? So meaning that SH is equal to UH is 200 cos theta times TAC. TAC is equal to 2 times TAB. So this will be 2 into TAB, which is 20, 20,408 sine theta. Right, so let us do this. Right, so this is 20,408 sine theta. Right. Therefore, SH will be equal to, now what is, because we're multiplying everything, so we can just say 200 times 2 times 20,408. Right, and that gives us 8163,2 times cos theta times sine theta. Right, so we have the equivalence of the horizontal displacement in terms of theta. Right, now we are going to do the same for H max. Right, now we have to get what H max is equal to. Right, also expressing H max in terms of theta. Right, be it sine theta or cos theta. Are we still together? Hello?
Yes, sir. I just want to ask, with that, the value, where do you get the value for G on that equation for calculating time? Yes, sir. The 9, the value for G. I see
What
you
about
put
it?
9. Where do you get that value?
Where did I get
the
value?
The G. Yeah, because you said it's 9.
It's 9,8.
When you calculating GT on the time equation.
Where did I get the 9,8?
Yeah, because I see you putting there when you doing the time calculation on that equation formula. I'm asking, where do you get that value for 9.8? Is 9.8 or 9?
It's 9,8. That's the value for gravitational acceleration, G.
It's gravity, Buddha. It's gravity.
Oh,
Yes,
okay, right. No, when
acceleration.
so you put it 9.8.
Yes.
All right, no problem, sir.
Right. For engineering science, we do not use 9,81. We use 9,8.
9.8.
Yes.
All right. Thank you.
Right. Now, as far as H max, right? H max is on this side of the projectile. Right. We get H max, right, when the when the projectile moves from point A to point B, right? That is when we get the maximum height, right? So using that side of the equation, that side of the projectile, now you have to decide on the projectile. Just mute yourself, people. Nah? And then if you want to say something or want to ask something, just unmute yourselves. But as soon as you are done speaking or answered your question, just mute yourselves again there. Right. So because of that, we have to decide on the most convenient, what is this, equation of motion, which in this case, based on what we've been given, right, will be v y squared is equal to uy squared. So the original equation has a plus, but we are going to use minus. Why? Because g is negative. Am I making sense here? Right. So this is negative because of this. Do you understand what I mean here? I need someone to say yes or no.
Yes, sir.
Yes, sir.
All right. Remember, when I ask a question, I need for you guys to answer me, because the thumbs up, I cannot see your thumbs. Right. So the reactions I cannot see. So just unmute yourselves quickly, answer me, then mute yourselves again. Right. Now this is 0. Right. This is at the apex. That's 0. And then uy is 200 sine theta, all of this squared, minus 2 into 9,8 times h max, right? Now 2 times 9,8 gives us 19,6. That 19,6 is negative, so we're going to take this term to that side, hence it becomes positive 19,6 h max is equal to 200. What is 200 squared? So essentially here you will have
40,000.
40,000 sine squared theta, right? And then you solve for h max, making h max the subject of the formula. So this becomes 19,6 divided by 19,6, right? Therefore h max is 40,000 divided by 19,6 is 2040,816 sine squared theta. All right. Now, what we have done here, right? Now, this is for any and all questions that are like this, right? That are in this format, right? They want us to calculate the projectile. The only way we can calculate the projectile in this case is if we express this in terms of the angle theta. So that is in terms of either sine theta or cos theta or whatever the case. Similarly with h max, we have to do the same, right? Once we have an equivalence of this in terms of the angle and the equivalence of this in terms of the angle, we then equate them and solve for theta. Right? We have SH, right? It is in terms of cos theta sine theta, and we have H max. It is in terms of sine squared theta. Right? Now we go back to using this equation. Right? This equation is SH. Right? Remember that SH is equal to 5 times H max. Now, what is SH equal to? SH is equal to this.
Hello, sir.
Yes.
If you can just quickly remind me, for that displacement horizontal, right? Where do we get the 5 from? It's equal to 5 times H max. Where do you get the 5 from? Oh,
H.
yes, up there. Okay, thank you, sir.
We were told, yeah.
Thank you. Then got it, sir. Yeah.
And then, right, on this side, right, they said SH, which is this, is 5 times that. So here you have 5 into H max. Right? So essentially what we have is this is equal to, now we say 5 times 2040, 816, which is 10204,08 sine squared theta. Right? Now obviously here, right, on both sides of the equation you have sine theta. Right? So that means this cancels, right? And obviously the squared goes away. Am I making sense here?
Clear, sir.
Right, so obviously that goes away, right? And then you'll be left with in fact, because it might not make sense to some of you. Let me do this. Let's take this step by step. So if you divide both sides by let's say, yeah, by sine theta. So obviously that falls away, and then this cancels with one of those. And then you'll be left with this on the left hand side is equal to this sine theta. Right? Now you have two trigonometric ratios, cos and sine. Right? So the best thing to do here is to use cos and sine, right, and turn them into tan theta. Now, what is tan theta equal to? What is tan theta equal to, people?
It's equals to sine over cos, sir.
Yes. So tan theta we know is sine theta over cos theta. All right. So we have to manipulate this equation such that it suits this condition. Right. So meaningly, we divide both sides by cos theta. That way, on the right hand side, you will have sine theta over cos theta, which is tan theta, right? And then we also have to get rid of this. So we divide by this both sides as well. So essentially, we divide by 10204,08 cos theta. Let's divide this by that. And then we do the same thing on the right hand side. We divide by 10204,08 cos theta. Right, and then on this side, obviously that cancels. On the left hand side, that cancels. And essentially what you are left with, sine theta over cos theta is tan theta. So we essentially have tan theta is equal to this. Right, this is 8. Yeah. And then to get theta, we have to calculate arctan of this. And then arctan of H163,2 over 10204,08 is 38,66 degrees. Again, the same thing here.
Same thing on my side.
Yes, yes.
Right. The most important thing here is that in these kind of problems, right, when you are looking for the angle theta, you have to express this in terms of the angle or in terms of one trig ratio. And you have to also express this in terms of one trig ratio or two trig ratios, right? For instance, this one we express in terms of cos theta, sine theta, right? That is just how things worked out mathematically, right? And then you also express this in terms of trig ratios, and then you go back to this, right, and equate these two, and then solve for theta. Any questions? Any questions?
None from me.
I will send this. I will send this document.
How many marks was that question, sir?
Let me see if there's one similar to it here. None of these. None of these. Angle. Okay, angles. Oh, there it is. 2.3 here. Right. So I'm going to send you this document. Right. You are going to go to page 2, and you are going to attempt all the problems on page 2. The answers are correct as well, so you can trust those answers. So the answers that I've given you here, right? If you don't get anything close to those answers, then it means you did something wrong, right? But a question similar to the one I've just done is 2.3. The first 2.3, or let me say the second 2.3 from the bottom. There will be 5 marks. Now, obviously, once you are used to doing such problems, you will find a much shorter way of doing them. All right, I will do them as well on my side and then send you the solutions. Nah?
Okay, sir.
Okay.
Right. Just check there if they got, or maybe let's check here. This is activity 1.4, number 10. Number 10. They got 38. What did we get? They got 38,6. I think we got the same thing. Yeah. So it's correct. 38,66. Yes. Right. B, calculate the maximum horizontal displacement. All right. So this one is pretty straightforward. We already know that this is equal to that. All right, so all you do is substitute theta here. All right, seeing that we already have the angle theta. All right, so this, for instance, would be 8163,2 times cos theta is 38,66 times sine 38,66. So I'm getting here. So this essentially is so for B, we know SH is equal to this. And then now you substitute 8163,2 times cos 38,66 times sine 38,66. And here I get 3982,055. Right, that one is pretty straightforward. Right, any questions, comments, anything? Right, projectile motion is very easy, people, but like I said, you have to keep your solutions in the context of what you've been given. Right, if you do that, if you do not do that, you will find questions where if you do not do that, if you use, say, 2, maybe 3 approaches, you get 3 different answers. Right, the only reason why that happens is because you haven't quite kept your solution in the context of what you've been given. Always keep your solutions in the context of what you've been given. Are we clear?
We're clear, sir. Sir, could you also do an example in the textbook?
Which example?
Example 1.14 on page 24 of the new textbook.
Example
1.14.
This one. A canyon is situated on a building which is 50 meters high, fires a shell horizontally at a velocity of 280 meters per second. Okay. The time taken until the shell hits the ground. Okay. Right. So this will be the last exercise I'm doing on projectile motion, people. Though this question, horizontal, okay, the question seems a bit different from the others, but let's do it anyway. You can see the question is different from the ones I've seen though. All right. Let's see. So this is not moving from the ground and then back to the ground. They said a cannon situated on a building which is 50 meters high fires a shell horizontally at a velocity of 280. Okay, so let's draw the schematic illustration of this. This is moving from from a building. So you have something. Maybe, okay. Something that looks like this. You can take this as a building.
Sorry, sir.
A building, yes.
I'm still stuck on the previous question. I don't see the second one that you are doing.
You don't see the second one I'm doing?
Yes, on my screen is still the previous question.
Okay, let me just. All right, what do you see now?
Still the same.
Still the same.
The same.
Yes.
Okay, I have no idea what happened with this. How about now?
Still.
Still can't see the question?
No.
Technology sometimes. Just. Okay, I'm going to log out and then log back in. Now I have to stop the video. Because I have no idea what's going on. All right, I'm just gonna